This was the n, right? We did the n and double. Yep.
It has one test case.
Yeah.
Zeros.
Oh, interesting. One answer I came up with passed whatever 599 out of 600 test cases as well. So it's a little bit when we'll show you sort of why that can happen. Oh, you did? Okay.
Because like zeros double is also zero.
Yeah.
And it feels like, no, it's not.
That doesn't count. Don't use zero. Okay, I don't really want to see that. Cool. All right, so let's go ahead and start with that. Who are we missing? Anyone for? Yeah, who are we missing? We're missing Ethan. Yep. Okay. Logan came in. He's on Zoom because he's not feeling well. So, which I just at this point of the game, if you're feeling sick and coughing, Zoom into class. Like there's so many gnarly things going around, and that's the last thing I want for a break. So don't come to class. Okay, so how did people go about solving this thing?
Double loop.
Double loop. And is it pretty easy if it's a double loop?
Yeah.
Yeah, what do you do if it's a double loop? So what condition?
If they're not equal and whatever they are equals to 2 times r.
Okay. Just the double?
Yeah.
Okay. Go ahead and share your code. Let's see what you got. What's that, Sienna? Yeah, this one's pretty easy to do in O of n squared, right? And I wouldn't expect you to know how to do this in anything faster.
Well, you can look at hash map.
Right, but how many of you know how to do a hash map? It did say about a hash table. Yep, and that's what we'll look at because Tony, you want to go ahead and share yours? We'll go ahead and look at what a hash table looks like. We did briefly see this, and I'll show you where we've recently briefly seen it because it's a really useful thing. And we do loop back around to it. We'll look at hash tables and hash maps. Tony.
Is it 105?
It's right there on the board. 115, yes.
Right.
All right. If I does not equal j, why do we have to check if I does not equal j?
That's in the question. Then I would check the same thing.
If you go from 0 to I, then you don't have to check.
Yeah. So what did you do? How'd you do it differently, Mary?
Oh.
Go from j equals 0 to j is less than I.
No, but
We can do I or j equals
J equals I. If j equals I, then the only way we're going to get that is if try it and see. We're going to run into potentially the problem Sienna ran into, but let's do it and see. Run the code. So this presents us with a slightly different trick. What else did you add, Mary? Did you add something else or not?
J equals 2 times I.
Oh, like
You can switch the conditions, or the other way to do it, that's the easier way to do it. You could also check if it's half. But if we check if half, what do we have to do then? Because what's the problem with taking half of 7? We get a double. You wouldn't want to probably cast it. You would just want to check to make sure that it is an even number first.
could have just done it in Monterey, I equals 2 times right there.
Or flip it. Yep, that's the easy way to do it. Or you could have, or you could do this for both from 0. What happens to our runtime? So go back to j equals 0. Put all your just hit Control Z a couple times, and it'll put it all back. Command Z a couple times. And let's just see what you're, yeah, go ahead and do more details. So we have, okay, your runtime, actually, that's
So weird.
funny that your runtime's here because what runtime are we at? O of n squared, which is not great, okay? So obviously they're putting in really fairly small arrays here. And actually at some point they say that our array is, I'm gonna go ahead, you go and stop sharing. We can see that our array is very small in that it is only up to 10 to the third. Okay, arrayed out length is less than 500. Well, this is a small array. So the O of n squared is not a particularly big deal. If we got bigger than that, then we'd start to run into issues. Okay, so how do we do O of n? Well, if we go back and you think back to, this was the crash course that we did like maybe the second day of class. There was a couple things in here that you hadn't really seen. We saw, for each loops, there was lists in here. But if you were paying attention, there was two other things in here. There were sets and there were maps. Okay. And so what is a set? What does that mean?
Things, but there's no like double, like there's no thing, anything twice.
No duplicates. And the other thing about a set is because it's what's known as a hash set, okay? You'll see this down here. Hash set does not have a defined order, but is usually fast. So typically lookup in a hash set is O of 1. Okay? So it's not, lookup inside of a set is not particularly difficult. So given that piece of information right there, and we also have a hash map. A hash map allows us to put in two things, a key and a value, okay? And again, if we go through this thing, pulling something out, looking at a key is super fast. If we use a hash map, no defined order, and is usually really fast, okay? In other words, O of 1 for lookups. So what could we do here to solve this thing?
You could do it. Just put your values in the key.
What values?
Your array value.
What array value?
Like the array value, like every item in the array.
Do we really want to do every item in the array? We're trying to do one pass through the array.
Oh.
Compare the two things.
What two things do we want to compare? Well, if we think about going through this thing, if I'm going through this once,
Wait, you can put like
right? And I would look
array
at that
times
thing.
2, array times 2 into the map, and then you run through it and check if there's a value.
Just array times 2? What did we just say about
And the
one pass through? Because if I do just array times 2 and I do this one, I'll never get it. If I do one pass through.
wait,
There is no, I get to 2, there is no array times 2, there is no array times 2, right?
yeah. Wait,
What do I want to check for? Actually, it will be, but it's not the other way around.
what do you mean by that?
Well, let's rearrange this. 5, 2, 10, 3.
Yeah,
Okay? I'm doing one pass through. Is this number times 2 in my map?
yes.
No,
Oh.
there's nothing in my map.
Oh, you gotta add it first.
Add what?
5 times 2.
Okay. I add that to my map.
And this at like what the value. Like 5 times 2 is the key, and then you have to set the value with the
But is 5 times 2 in my map?
no.
No. So it's not there. So I can put it in my map, but I'll never get back to that again.
Wait.
So what do I have to check? Because think about what I'm doing. I'm putting this in a map as I go through. I'm going to say, hey, is 5 times 2 in my map? No, it's not. If I did that here, if I said, is 10 times 2 in my map? No, but I'm going to put 10 in my map. And then I get to 5 and I say, is 5 times 2 in the map? Yes, 10 is in the map. We're good. But if the 5 is here and the 10 is here, 10 isn't in my map to start. Divided by 2. Because then when I hit 10, and I say, hey, is 10 divided by 2 on my map? Yep, it is. We're done.
Oh,
Oh. Okay. Yep. And we actually don't need to use a map. We can use a set here. We have to use a map. And this, I actually used a map the first time through because in other problems like this, it's often not a Boolean. What does it often want instead?
the values.
The indexes of the thing. And so a map, you have to use a map in that case to keep track of the index that the number's at. Because typically it'll say, hey, give me the 2 indices that these 2 things are at. And then you use a map because you can keep track of the number 10 and the index that it's at 0. Right? Because my key value pair would be key is 10, my index is 0, or the other way around, right? Because I might run into 2. Okay. Does that make some level of sense? Sort of, we create a set or we create a map. We just go through if the thing is, and I look for half and I look for double. Okay. And so what that looks like in actual code, I did this like 6 different ways. So I had, well, this is the half the nested for loop. So if I iterated through and just checked if twice the array or just flipped it like you guys did, that works. Okay, I'm gonna get rid of that because I don't like it. Okay, I'll give you 2 other solutions here. So this is a messy version of a map. First thing you should do is check if the length is 0 or the array is null, return false. That's why do we do that first?
So we don't have to, if it is, you don't have to go through the entire thing.
Yeah, it makes it much faster, right? I create a map, integers to integer. I iterate through 1 time through, and then I did this assigning these 2 values twice equals this. What I initially did is I was like, oh, half just equals, -1 because that'll be easy. And then if array at I equals is even, I can divide half, and then I just use the way you do the terminology in map is contains key. So if the map contains key for this, or the map contains key at half, return true. After that, at the end of the for loop, we put that thing in there if it's not there. Right. So with the example of what did I say? 5, 3, 10, 2. When I get here, right, I put 5 in the map. So when I get to 10 and I say, hey, is half of 10 in here, it goes through, and yes, it contains that key. Okay. The problem is this seemed to work. There we go. Oh, no, half of 1 minus -1f. That's not what I wanted. Half equals -1. Run code. True, submit. So this is what I was talking about, Sienna. So you can go into more details because it's like, why am I not passing this one? I passed 110 of 111 test cases. So what's causing me trouble? 1 test case. Specifically, if we look through all this, I've got some negative numbers in here, which maybe I wasn't really thinking of. Yeah, I put -1 in sort of as a like dummy number, and it's not a good dummy number because clearly that -1 as a half is causing me trouble. Okay, and I'll be honest, I don't know quite how or I didn't go through the problem deeply enough to figure out why it's causing me trouble. But if I just set it at min value, this works fine. Okay. We can tighten this up a lot because I really don't need to declare all these things. I can just do this. Whoops, wait, what did I do? Get rid of that line too. Whoops, nope, just that one. So if map contains key, array times 2, or array at I modulo 2 equals 0, so it's even and map dot contains key. Why do I have to put this first?
Oh, to check if it's even or not.
Check if it's even. right? Because if it's not, I don't want to do this, and it'll short circuit if it's odd. Right, remember our short circuit? Right, so it short circuits if it's odd, because I don't want to get over here and have it throw, and say, hey, this is a double, and can't do that, okay? So this is the map way of doing it. This runs, and the funny thing is, again, with this small a set of numbers, it doesn't run all that much faster. So there we go, 93%, which was, what did we get over on the double for loop? On the runtime, I think it's 1 millisecond faster, something like that. And then finally, we don't need a map because it's a Boolean, because I'm not trying to return the indices that this thing is at. So I could just use a set for all these things. And the nice thing is in here, we don't need to like import all the different things. Set.put nope, set. What did I do? Oh, I can't have two things in there because it's a set.
You can say, create the set and the hash set and then say not.
Yeah, remember, so this is exactly what we're learning in class. So this is part of the nice thing about this, right? This is obviously what is set? Not obviously. What do we think set is? An interface. That's an interface. And then I have different implementations of set. If we go look at this, actually right here, we can see that it says that there's two main implementations, tree set and hash set. Java has the set interface, okay? So that's the set interface. And then tree set, we're not going to use that often, but hash set is super handy. Whoops, here we go here. What else? Screwing up.
Takes like the doc container, uses the doc containers method.
Yeah, except it's not put. What is it with? Let's see. I can't remember. We can't add, right? So we're not adding. We're not putting. We're adding. So map dot add. I should probably call it set too, not add, not map. But I don't want to change everything. And it's not contains key because there's no key value pairs. It's just contains. I do get those confused sometimes. I often want to just say contains, but you got to look for specifically for keys in a map. So you got to be a little careful with that. Oops, come on. Oh, yep, I can't add. All right, we'll figure this out slowly. We'll keep making mistakes and debug it. There we go. Okay, now let's see. This should work. All the logic is the same. There we go. And this should be a little bit faster, but it's not. And the funny thing is, the memory usage at this stage of the game with a thing this small, memory usage, it's sort of meaningless. A set should take less memory than a map, like not significantly, but it should take a little bit less memory than a map. Yeah, what's up, Max?
What would make the it take the most memory? Like you see it all the way on the right. Like what would be making it? What?
So they're using a stream, array stream. So yeah, they're trying to be fancy with their
What would that do to the runtime?
runtime should be reasonably fast, but it's just going to use a fair amount of memory. And the difference in memory, if we're looking at memory, right, we're here. And if we look at the difference in, 4,300 versus 4,400, it's negligible.
Wait, so as runtime decreases?
No, don't go there. No, there is not like an inverse relationship between runtime and memory usage.
Okay.
And there can be, but I wouldn't try to make some sort of equation between the two. Nope. No, don't be sorry. It's a good question, but I wouldn't think of it that way.
Oh.
Yeah.
Yes.
Okay. Questions on that one? So that's using a set, and it's again, I guess that was my map. Sets and maps, we will get into these more, but just sort of to give you a preview of the fact that there are data structures that we're going to be able to use further down the road that let us get to O of n or O of n log n as opposed to n squared. And that's the whole point of some of these more advanced data structures. And then the other one is this structure here, right? I've got an interface. This is what, again, let's go back to our, what What do we call this?
Instantiation.
Instantiation, but what type? What do we remember what we did? This is our static type, and this is our dynamic type, right? So our hash set. So obviously, if we called a method in hash set, what would we want to make sure of? That it's in the interface. And that's the whole point of the interface, is that it demands that all those methods are in your dynamic type.
That's what like our potential client would see, right?
Yep. Yeah, client's only dealing with the hash set, and specifically actually client's only really dealing with the methods of the set. So let's look at that. Oh, thank you. I'll pay you later. So that's going to take us right into this, which is we were talking about higher order functions last class. So this is subtype polymorphism versus explicit higher order functions, which is just a whole bunch of big words. But specifically what we're looking at is, first of all, what is polymorphism? Because it's a big piece of object-oriented programming, OOP. What is polymorphism?
Consider what we just did with the implements and the set and hash set, so that polymorphism.
How so?
Have different instantiated type and declared type.
Yeah, exactly. So if we have this thing, we've got a variable deck. It's of a static type deck, and we call deck add first. What's happening? What's the code under the hood?
It's gonna change the form of the deck, like if you add first, it's gonna like search everything.
Okay, so what is your add first method going to look like? What's the code for the add first?
The static,
What do you mean?
like, it's gonna call the add first method from the static type.
Well, the static type is deck. But what's the implementation of it? Huh? Your array deck? Necessarily? Sort of a trick question. What is the code underneath the hood? There is no code in the static deck type. It's an interface. There's just a method name.
Well, there's nothing, we have to create the code. How we create it or not?
It's a Boolean. Add first is a Boolean.
It's a void,
What do you mean? It's a void.
like no return, no return.
Add first has a no return. Okay. So what's the code?
Sentinel.next equals next,
Okay.
right? Yeah, and then like, yeah,
Okay.
and then Sentinel.next equals Sentinel dot.
Okay. Do we want to agree?
Yeah, like,
All right, what's the question?
One of the questions, what's the code for add first? We've got this deck, static type deck. We call deck.add first. What's the code? Oh, no, let's assume, this works. We go make it happen. What's the code? It doesn't, say that again louder, Mary. It doesn't matter. We don't care what the underlying code is. Right? The whole point of polymorphism is that when I call add first, what could be under the hood? What were you just describing the add first method for?
bring deck.
An array?
Linked list.
A linked list deck. Right? That's where the sentinel.next would come in. If it were an array deck, would it look different? The code would be entirely different if it were an array deck. We don't care what the code under the hood is, as long as it works. Our deck just needs to have an add first and it needs to work. Okay, and that's what our client cares about. Now, if I have a dynamic type that's a linked list deck, okay, that underlying code is going to be one thing. And if I have a dynamic type that's an array deck, that code is going to be different, but we don't care. Okay, the behavior is based on the dynamic type, but Java automatically goes and figures out which one it is. Okay, so when I call deck.add first, it's static type deck. And so it has dynamic method selection. Okay. Okay. Here's where it gets fun. We want to create a program that prints a string representation of two larger objects. This is our higher order function. We say define print larger. We pass in an XY. We pass in some method called compare. Okay, and we pass in some method called stringify. I don't know why. And if compare xy, we return stringify x, otherwise we stringify y. So what does compare, what compare must do here? What? Yeah, it's comparing this to this. If this is larger in whatever way that is, then I'm printing that thing, otherwise I'm printing this thing. This is subtype polymorphism. We're gonna say, hey, print larger, we're just gonna pass in the x and y. If x larger than y, return x dot string, return y dot string. Okay, that's subtype polymorphism.
What does that mean? So.
Well, we didn't actually define polymorphism. What is polymorphism? Literally like from Latin.
Many more.
Many forms, right? So subtype polymorphism, maybe this will make more sense. When we go in and we try to do this, here's what we're going to try and do, Daniel. We're going to try and build a function max that returns a max of any array regardless of type. Okay? So if we think about what subtype polymorphism is, we want to be able to go in and say call larger or max or whatever, right? And then this whole thing is going to be determined not by passing in functions, right? But it's going to be determined by what like this method is inside of that class.
Oh,
Okay?
so determine which one to use.
You got it. Okay? Okay. How do we do this? What would this look like? Oh, we can pretty easily think through this. How would we think through an integer array? Yeah, we're just gonna use a greater than sign, right? The code's gonna look something like this, right? We're gonna iterate through. We're gonna set max dex. What should our max be equal to?
Integer, min integer, or max integer.
And the first one.
Yeah, usually the first thing. We could use min integer. That would be the
Or
other.
min integer.
If it's less than.
Yeah, if these were all less than 0, obviously, if we're looking for the size of a dog, we're not going to get negative. So 0 would be okay, right? But if we're using other things, if we're using array of integers, then we'd want to use either min integer or just the first thing in the array. We're going to iterate through if items at I is greater than items at max dex equals I, return, boom, right? Cool. Now down here we have in our main method, we've got an array of dogs. Okay, we got 3 dogs in here. We call dog max dog equals dog maximizer max dogs max dog ducks barks.
Can you move that to them?
This?
If you want us to give you the code for them, or not?
Say again.
Like, are we trying to-
This is the code for it, sort of. Okay, because we've passed in. Let's look at it and see. How many compilation errors are there in the code below? And you've specifically got 3 things to look at. Or are there any? So we get 0, 1, 2, or 3. Give me just a thumbs up when you have some idea of an answer that you're comfortable with.
Or assuming the bar method is.
We're assuming that we have a dog class and then we have a bark method. Yep. It's the name, the name of this particular class.
Wait,
Yep.
Can you cast an object as a dog?
Okay, so you're asking, can we cast this thing?
Yeah.
Didn't
Okay.
we do that last class?
We did do that last time. Let's start with that. Sure. If we have maximizer, what is maximizer.max going to return?
A dog.
No,
An object.
it's going to return an object. It says it right up here. Public static object. So let's tackle this one first. Can I have an array of objects?
Yeah.
Yeah.
Yep. So does this have any problems?
Nope.
Nope. Okay. This maximizer.max of dogs is going to return an object. I cast it as a dog and I say dog max dog.
Yeah.
Seems fine, okay. Okay, if items in I is greater than items in max dog. Any problem? So we're going with 0, right?
Wait, it says greater.
It does say greater than, yeah. Because we want, if this thing is bigger than this
How can
thing,
we do that?
we
with,
want to
like,
return the.
Dogs.
Hmm.
They have different attributes. It's not just comparing their weight, they have like a name and everything.
Yeah, so what's in this thing right now? What's the first time through? What's this thing?
It's a dog.
It's a lease 3, it's a dog.
Do I don't get any, or get
You'd have to do it. Like do graphically and then like.
Well, obviously we just ran into a couple of issues. One is what makes for a maximum dog? What are most of us going to consider, like, what are we concerned about dealing with in terms of our dogs?
Biggest, their weight.
Their weight, right? So we're not going to say biggest is like whoever's name comes first typically, right? We're going to say their weight.
Yeah.
So we could theoretically go in and say, okay, if dog dot get weight is greater than other dog dot get weight.
Yeah.
Okay, but what we're trying to do is write a function max that returns the max of any array. What did we just do?
We made it specific to dog.
We just made a dog array max.
We have to make it look at the type and then go to that specific class and do that method.
Which method?
The one in the dynamics, right?
override and
Override what?
like it could be like dog get biggest and then like within each class, it like overrides for what you need.
But override, but what piece are we overriding? That's what I'm not quite clear on.
It's like, oh, for like this, for the dogs, it's like,
Oh, so we override max in every class?
So we override the comparison.
We override the comparison? So we override this piece right here? No. However,
Bigger phone.
yes. Yep. No, so what we're going to do is we're going to ostensibly override, and you're going to be like, oh, in a second, but we're going to override this thing. Okay. So one bad way to fix this is write a max method in the dog class, right? So we're going to, I don't want to give anything away here, right? We could do this and we could do exactly what we just said, compare, we could go through this, make it just for dogs, max dog, we got an array of dogs. We grab the first dog, we iterate through dogs. If this dog's dog size is greater than max dog, right? So just what we said with dogs. Does this code make sense? Great. But we can't compare all things like we saw with that greater than sign. Okay, so what we're going to do is we're going to build an R comparable or comparable. Okay, so open up IntelliJ. Here's our funky code for max. Okay, this is literally from what we just looked at. Okay. Yeah, new project, call it max or maximizer. See if I have my comparable in here. Whoops. Went to the wrong place. Okay. And we're going to create. Now, what should our comparable be? What type of thing should our comparable be? Well, we're going to have an interface that guarantees a comparison method. Okay. Remember, interface inheritance says what a class can do. And then we're going to have the dog implement this interface. So this is it. So we're going to have, well, what should our comparable be?
Yeah. Or like an object. Or like a Boolean class, actually.
Shouldn't be a class at all. Should be an interface. Right? So it's our comparable.java, public. What? Public interface, our comparable, and then according to our little thing here, we want one method, which is a compare to. Okay. And
Can we change our project name after we created it?
project name, no. Maybe, but I've never done it. You can change your class names, but you can't change your thing names. Okay. All right, and we're gonna do this with an int. So this is gonna be an int compare to. Now, what are we comparing to if we want this thing to work? An object. So I'm going to compare to some other object. Okay, X.
We're creating this max 21.
I'm creating it in max 24 because I need to keep track of the different times I've done this. So you can create it in max or maximizer, like I said. Because what we're shooting for is this thing, our comparable. And this is going to be our method name inside of this thing. Okay. So we've got this dog's going to implement the interface. We're going to write the maximizer class in terms of this thing. I wish I could get rid of this more. There we go. But then I can't get to my, come on. There we go. Try and tuck it over here. Okay. Okay, that's what our interface should look like. We could make this, instead of an object, we could actually make this an R comparable. Okay, which seems a little bit weird. But what are we going to have to do to be able to use this method? We're going to have to implement the interface, remember? And then can we compare, can we use that interface name when I'm doing things, right? In a method header, can I use list or set or any of those things in a method header? Yeah, I can. So this could be an R comparable. Doesn't really matter. And specifically what we want this thing to do, and we'll put this into our interface. In our comparable, we're going to say that this is going to, return a negative number if x is, if this is less than x, right? 0 if equal. And then positive if it's greater than, yeah? Would that sound pretty standard? If I'm comparing myself to something else, then I want it to be negative if I'm less than that thing. Okay, next thing we need to do is quickly write up a dog class. So write up a dog.java. What do we need for a dog class? Yep, so let's just do those two things. String name. Wait, what's that? It doesn't really matter. Yes, but I don't really care. Sure. No, don't make them private because that's going to make our life just several steps more difficult, which we don't really want for right now. Technically, yes, you should. We're going to have a public dog. We'll pass in a string n and again w, and equals n equals w. Okay. Okay. So we're going to, whoops. All right. So what do we need to do here? Where are we going to implement our interface? Which class needs to implement this interface? We now have 3 classes. We have some sort of max class or maximizer class. You don't have that, but you should add a maximizer class. So you should have this class here, max. Don't write in this code because we know it's broken. Okay, but you could put in the, and actually don't even put in that, but you can want to have a public class max. Where do we implement our comparable? In the dog class, right? So dog has to implement our comparable. Now it's got a nice big underline there because what do I have to do if dog implements are comparable? I have to implement the method. So I'm going to do that. I'm going to actually just step through and do it that way. Oops, where do we go?
Or you step on the number.
There we go. Okay, so I'm going to return 0. I've got this thing. What do I want to return here? So I could make this kind of fancy. What could I do, right? If I'm comparing this dog to some other dog, what do I want to do?
It's not weight is greater than.
So I could do if x dot weight is, I'm going to do it the other way around. If I'm going to say if this dot weight is greater than x dot weight, what do I want to do? So if my weight is greater than, yeah, sure, we just return 1. Oops, what did I just do there? Return 1. Else if this dot weight is less than x dot weight, right? So far, so good. Why is it not liking weight right there? Can that resolve the symbol weight?
Because it's an object, not a dog.
No, because you don't have X in this.
Yeah, that we'll see that in a second. Yeah, you're right. So this is good call, right? What is X not? Why doesn't X have a weight? It's not a dog. So we got to think about that one too in a second. Return -1. Yep, else return 0, right? Yeah, let's do it just because we want it to return something if they're the same size. Okay.
You have to put it outside the house.
Yeah, I have to put it, because otherwise I'd have an if, else if. I mean, could I, but it's just easier to put the else in there. Yep. Because I already have the else if. If I didn't have the else if in there, yeah, I could probably do that. And I don't need anything there, right? Okay. It also, yeah, okay. So clearly I can't call x dot weight because x is an object. So what do I need to do here? Should be a dog. Cast it. I can cast it as a dog. So let's think about how I want to do this. I could say dog, other dog equals what? How do I cast it? Parentheses, dog, x. And now instead of my x dot weight, I got to put in other dog. This is why it's easier to keep, keep your variable name short. There we go. Now I don't see any little red there. I don't see any errors going on. Cool. Now if I come back over to Max, now go ahead and write Max. And we should be able to get this. Oh, we don't have a bark method. We could just print out. Do we want to write a bark method or do we want to write a toString for our dog so we get something that's useful? All right, we'll write a toString for our dog. So in here, down here, public, because we should always override our toString, theoretically. Return name plot what do we want to say? Plus space plus weight. Sure. And that way, when we come over here, instead of calling maxdog.bark, we'll just print maxdog. Right? If we've done this correctly, we should be able to print out. Oops. We should be able to print out maxdog. So this code needs to change right in here. And we got to think about what we need to do here. Equals 1.
If items I dot compared to items that whatever's the max, then.
Yeah.
Compared to what?
Object does not become.
Hmm. So we got to think a little bit about that piece, right? Which is I'm returning an object and I've taken in an array of objects, but an object doesn't have a compare to method. What has a compare to method? But remember, my max method wants to apply to everything.
Added like a exclamation mark.
Huh?
What?
What do you mean add an exclamation mark? How did I get those two things there? Where am I adding an exclamation mark?
The word, very good. Never mind, it's like a.
No, don't want to do that. Think about where am I getting compared to from? Am I?
Database.
The interface. So what do I actually want to return?
Oh.
I want to return an R comparable.
And when we return it, do we? Can we what? Yeah, save as a.
I mean, it's the item that doesn't have compared to item.
Well, okay, so what else do I need to change?
Change this to our. No.
Change what? What did I say we could do here instead of having compare to object X? What I literally just say we could change this object to here. R comparable. So what do we actually have an array of?
Interface.
R comparables.
Array of interface.
Now, this thing's going to throw an error, but it's going to say, hey, oh, we got to make sure that compare to is what? We don't want to just say items I compare to items at max dev. Say again, Mary? I could say equals 1. We're going to say greater than 0 because you'll see why in a second. Okay. Whoops, I put that in the wrong place. Compare to, that's there and that's there. There we go. Now, if you create that array of dogs in your main method, why am I still not getting a, what did I do here? That's closing our comparable. Wait, what did I do? Oh, I got rid of an extra. Yeah, all right, there we go. There we go. All right, so when I run that, let's see, who should be barking? Missing return statement. Benjamin should be barking. Where am I missing a return statement from? Max. Turn. Oh, because I was messing around with my curly braces there a minute ago and got confused. Okay, we got to return our dogs down here. And Benjamin should be barking. Woohoo! There we go. So now our goal, okay, was to be able to pass in any type of object, right? And get what? All right, I know I went really fast through that. So we need a dog. We need our max method. And we need to make sure that we're actually doing our comparables so that our array in max should be our comparable. Think of the name. Stir? Oh, yeah, stir. It sounds kind of German to me. Stir. Yeah, so you got the joy of making up your own variable names. Reached end of file while parsing many lessons block off.
I don't know.
Where are you reaching in the file while parsing? In your dog. On line 19, so.
This is. Oh, we're gonna get that.
I'll say it. Oh,
Oh my,
when you're good. What's the super Dutch Java?
I didn't do super, so that's why, yeah. Not moving.
Okay, whoa, stop. Your comparable. Yeah. Should be in its own, why is, yeah,
It's supposed to be, it's,
yeah, no, that's supposed to be an interface. Go in here, why are you writing it up in? Why do you have? Yeah, because you should have another class. Right, so your max method should be its own class, not inside a dog.
do we change like the parameter and like are comparable to our company? Like in the like interface,
What about it?
we have to change the parameter of the.
This?
Yeah.
Nope,
No?
nope. Nope.
Dog is not a graph.
Dog is not abstract, no, dog, well, I mean, it's sort of abstract, I don't
I
know.
say that, I think. No, it says that in my error. I don't know why it said. Wait, can I see a different dog?
Can you see dog? Dog's got to implement our comparable. Okay, what questions do we have? Who's not getting this to work? Are we all having this work?
I'm seeing debug.
Yeah, no, it's just, I wanted to keep it like as a, as that, so then I wouldn't have to. First, so like everything. For you to mention, which they return, it's not zero.
Yeah, you for your maximizer?
Yeah, I wanted to see if I could do it as like an object, like because my thing that I'm checking it every single time is like an object thing,
Yeah, no, you want to have this
as it is.
fit as an in for right now, right? Because then you could just do it as compared to. We're actually going to simplify this a little bit. And we're going to see how this becomes, hopefully, if we've done this correctly, and this is why we did not do, Mary, this is why we didn't make this equal to 1. Because what do we think the easier way to make this work in here is? What would be a simpler return? If I'm leaving it as an int. Well, close, return. How do I get, remember what our compare to wants to return, a negative number. I'm going to grab this little comment right here. I'm going to copy that comment into here to our comparable and put it right here.
Multiply by -1.
Simpler. Return.
They're done.
Subtract them.
Minus other dog that way. What's this going to give me?
Either 0, something greater than 1, or something less than 1.
It's gonna give me exactly what I'm looking for, and I don't have to make all the comparisons. Okay, so this is going to be exactly what I want. I should be able to come back over to my max method and run it, and it should still give me Benjamin 15. Right, we could go in and just check this to make sure Benjamin was last. So I could make Elise 30 pounds and just make sure that now Elise becomes, yep, there we go. Elise is coming out now as my max dog. Okay, so that's one little thing we can do. What's another problem here? What are some issues with this? Well, what are some good things first? What's benefits of this approach? Here we go. What's some good stuff? What do I not have to do that we were sort of doing at the first?
We don't have to make a new max method for each, or comparable compared to for each.
Well, do I have to? I don't have to make a whole new max method for every object I create, right? I do have to implement compare to, but I don't have to make a whole new max, right? Right, and we can pretty much pass in whatever we want to, and we can call maximizer.max on any set of our comparables. Okay. What are some problems with this then?
Well, for me, Elise is coming out no matter what.
What is, sorry?
Elise is like it's returning Elise no matter like the way.
I'm guessing you have some sort of greater than or less than sign problem with your initial thing. Just as a wild guess. All right, so let's look at this. We're gonna look at a compilation error puzzle. We're gonna look at this specific puzzle. I'm gonna let him talk this one through because I think it's, we're gonna let him talk it through. What time do we go till? 30? Perfect.
From now. Let's say.
Videos and really want you to do this. Perhaps more than any of these other professional videos, I really want you to do this one because it draws out certain misconceptions that's surprisingly common and will confuse. Okay. In this question, you are given a dog launcher class. It creates an array of dogs. It then passes that array of dogs to the maximizer.max function. Okay. So much like the main method we saw. Here we have the dog class exactly like we saw before. I'm going to cross this out. And here we have the maximizer class. And in this maximizer class, we have one method. Public, static, are comparable max. There's no main method in the maximizer class. So now the question is, if we delete the compare to method completely out of the dog and leave everything else untouched, which of these 4 files fails to compile? Dog launcher, dog maximizer, or the actual interface itself, our dog. So think about that. Okay? I think this is just a very, and it's been however long it takes you to come up with an answer you're happy with. And if you'd like, you can use IntelliJ by grabbing.
Okay, here you go. Put your name on top of this. I'm gonna collect these. So A, B, C, or D, or multiple of those. Which one of those will fail to compile?
If we take out.
Put your name on top. Put question 1 because we're going to do a couple of these. If you remove compare to, right? So we're removing compare to. Which fails to compile? You want me to run through the question? You want me to, like, you want to hear him talk through it again? Or do we care?
We're given the dog launcher class. It creates an array of dogs. It then passes that array of dogs to the maximizer.max function. Okay. So much like the main method we saw before. Here we have the dog class exactly like we saw before. I'm going to cross this out in a moment. And here we have the maximizer class. And in this maximizer class, we have only one method. Public, static, are comparable max. There's no main method in the maximizer class. So now the question is, if we delete the compare to method completely out of the dog class and leave everything else untouched, which of these 4 files fails to compile? Is it dog launcher, dog maximizer, or the actual interface itself, are comparable? So think about that, because I think this is just a very, and it's been however long it takes you to come up with an answer you're happy with. And if you'd like, you can use IntelliJ by grabbing the lecture code repo to experiment on your.
No, you can't.
It's a single.
No, what? Don't answer it. You're writing down an answer, and everyone is. This is a quiz. A, B, C, or D? or A, B, C, and D?
Only one answer, right?
Not necessarily.
Like, we just assume the interface is gonna contain. Compared to, do we know that the interface contains?
No, we've got the R comparable, right? So we don't see the implementation of the R comparable.
Wait, so.
But presumably the R comparable has a compare to method, like
Okay.
it's just that two pieces of code. Yeah. Good to go? Everyone's got an answer? They're not changing it now? Gordon?
So we have
Thinking.
an R comparable interface, right?
Yeah.
Okay.
Yep.
Okay.
Did I restart it?
No.
No. Yes, I thought I did.
Let's jump on in. We go here and we go to our dog class and we say, we are going to delete the compare to method. And as soon as we do that, we see that dog itself no longer compiles. And the reason is,
Why doesn't dog compile?
Because it implements in R and there's no comparative method.
Yeah, right? If we say we're implementing our comparable, what do we have to have?
The method from R.
Have to have a compare to method. Okay, so that definitely fails.
seems to be
Oops.
in our comparable. So what does the compiler do? It checks our comparable and it says, do you have a compare to method? Well, in fact, you don't. So you're lying. You're lying about being in our comparable, and I'm not going to let you compile. Okay? So in this case, it's dog. It's the other one. Second question. Let's suppose we now delete implements our comparable and only this. What's going to happen? Which of these files, perhaps multiple, fail to compile?
So we've just gotten rid of implements are comparable.
We still have the interface, right?
The interface still exists. Yep.
Much wider variety of answers.
How about you?
I'll give you another 5, 4.
Wait.
Is R comparable in maximum?
No,
And compared to is in our comparable. Interface.
but this should be all one line. Public static R comparable max. This is just the max method. R comparable is its own interface
And what the methods in our comparable are compared to,
compared to period.
that's it.
All right. Answers up. Okay. So if we think about this, we'll listen to his answer in a second. What do people think?
C.
B, A, C. Wow, anyone going for B? B, all right. We got every single answer here. All right. Let's think about dog first of all. We'll start with B, right? Can I have a compare to method in here?
Yeah.
Yes.
Yeah.
Sure,
That's like the only.
no problem there. Maximizer, can I have an R comparable, and have a compare to method in this maximizer?
Yeah.
Sure. And R comparable, we don't even see, so presumably R comparable is just fine, because it's all of one line, right? So there's no issue there. Here, what's the problem with A?
Dog is not comparable.
I can't call, right? If I pass in maximizers.max dogs, this method is expecting what? An R comparable. Dogs is not an R comparable.
How would the interface work, because it doesn't have the compare to method anymore?
It does. We're assuming that the interface R comparable has the compare to method in it. That's all it is. So we'll let him explain it. He talks specifically about that.
Are comparable. And then delete this. And we see the dog seems to compile just fine. And in fact, it makes some sense, right? I mean, you don't have to be an R comparable to implement the compare to method, just like you don't have to be the actual Santa class to wear a Santa hat. I mean, the real Santa.
Some of his analogies are really weird.
But it doesn't matter if you're not really an R comparable. In R comparable, you can still have a compare to method. All right. So now that let's see, just keep it on. Oops, whoa, maybe. All right, so let's get rid of our comparable again. I don't know why I put it back. Let's look at let's say maximizer. Maximizer seems fine. How about our comparable? Seems fine as well. Dog launcher? There's a problem. Our comparable cannot be applied to dog. And what's that all about? Well, I'm trying to provide an array of dogs to this maximizer.max function. However, maximizer.max expects an array of R comparables. Well, the compiler has to think, is an array of dogs an array of R comparables? Well, it looks at the dog class, it sees no R comparable tag, and so that means no, a dog is not an R comparable, so an array of dogs is not allowed to go in this box. Okay. So in this case, the answer is dog launcher. That's the problem. So what, Josh? Okay, maybe I got that question right, but actually quite a lot of people get it wrong.
If it was like to implement R comparable, there's a method that's not in the interface, then it would work.
Sorry, what?
If it were to like the class were to implement the interface, and the method that's not in the interface is in the class, then it wouldn't be fine. That would be the argument.
One more time. We implement the interface.
Implement the interface.
Yeah.
And you include like a method that's not in the interface.
I can have as many methods as I want to in dog.
No, well, like a method that's not in the interface.
No,
I can have as many methods as I want to in dog, including 27 that aren't in the interface. Right? This compare to method, I can have a compare to method in dog without R comparable.
So there's no, okay, that makes sense, yeah.
Right? Because we have a two-string method. That's not in R comparable. We could have a bark method. That's not in R comparable. Right?
Yeah.
Okay. So Daniel, your question earlier is, can I have this method maximizer and this interface R comparable and never ever use them? Yeah.
So it doesn't care as long as you don't. So, but if we. Okay.
Yeah. Okay.
That just makes R comparable
Useless. It's just never used. Yeah.
I was surprised how many people thought the answer was maximizer. And the reason is, students figure, oh, well, you're trying to compare things that are not actually R comparables. However, remember the compiler happens before any code is even run, right? It's a verification that everything checks out. And in fact, if you look at the maximizer class, I mean, it may be that nobody's ever even implemented R comparable. Maybe this code was written 2,000 years ago. The only thing they had was R comparable and maximizer, but they hadn't yet implemented it as dog or cat or horse or a list or anything. There were no R comparables, no actual specific instantiations of this, just the interface. This code operates at a higher level of abstraction than all of that. It doesn't deal with the earthly world of dogs and so forth. And so it shouldn't matter what anybody does in terms of messing up the implementation.
Okay. That's that. So I will I'm gonna give you some reading for homework for next time, maybe another leak code as well. Otherwise, have an awesome rest of your day. Yep, I'm taking your cards. You'll get back at some point, because we gotta go do a few more things for this. I'm still trying to figure out exactly what we're gonna end up doing.
Right answer.
With our final exam time, because we have to use an hour and a half of the 2 hours of our final exam time. I have a worksheet that I think is what we're gonna end up doing. This quiz?
Yeah, so.
Maybe. It's the only grade I have for you for this, this part of the term, Alex, so
A gaming competition or an app.
All right, have a great rest of the day. Yep, I will see you shortly. Yep, I will see you.
We can create a method.
Yeah.
Are comparable.
Thank you.
Yep, see you later.